One other thing that I want to implement is emission by distance. So again, if we scroll this animation, you will notice that no matter how far these pieces have traveled, they continue emitting particles. And this is also something that I want to be able to control. So again, we will add a point wrangler just below the kill by speed. So first of all, let me change the colors of these nodes. Now let's add the point wrangler. We will call this one set travel dist for travel distance. And this will be an arbitrary attribute. You can name it whatever you want. So let's change the color of the node again. And if you remember in the previous chapters, we've talked about the rest position or the rest node. And even if you didn't check out the volume 2, if you try generating an RBD simulation from scratch, you'll notice that a rest point is added just before the packed primitives. So we will need that to calculate how much distance has each piece traveled from the start. So this is something we now need to implement. So let's go back before we started simulation, just before our out fragments node. And here we will lay down a rest node. And since this change is happening before the simulation, we will need to recache the files. So select now your ROP geometry output and click Save to Disk. When it finishes caching, to select your file node and click Reload Geometry. So now if we check our unpacked primitives, go to the geometry spreadsheet, we should have here under our primitive section a rest position. And if you don't see this rest position, again, remember we need to tell the unpack primitive to bring in this attribute. And actually it's a point attribute, so here it is. So it's a rest position, it's a vector, X, Y, and Z positions. So now what we could do with this value is similar to what we did with the velocity. Calculate the vector, in this case the position of the point, and see how far from its original position has it traveled. And if the distance is too long, we will just delete it, just as we did before. So the implementation of this system will be very similar to what we did with the speed threshold. So let's go back to our emitting geometry. And here below our set travel distance, we will lay down a point wrangler. Call it kill by travel distance. And let's write the code to generate the attribute. So first of all, let's declare the name of our attribute, and remember it's going to be a float value. So type f at travel dist will be equals to the length of the rest position minus the current position of the point. So at p would be the current position, close the parentheses and type semicolon. So let's type Control Enter to evaluate. And let's take a look at our geometry spreadsheet and see if we have that travel distance value. So here it is. And we can see that some points have traveled 2.1 meters. Some points have already traveled more than 7 meters. And again, we will use this to delete some of the points in the geometry. And actually, this time, the farther the points are, the most probable it will be for them to be deleted. So now for the kill by travel distance node, what I can do is copy the code from the kill from speed with Ctrl+C, paste it on the new kill by travel distance node with Ctrl+V, and this time the if statement needs to evaluate if the travel dist attribute is greater than our threshold. So press Ctrl Enter to evaluate. Again, don't forget to create the actual channel. And right now, since the default is 0, every single point will be deleted. But as we increase this value, we will get back the closest points. So now notice how these rocks that are furthest away are being removed. Of course, we can bring them back. And this may be better to see through the camera. So here on frame 18, the distant rocks will stop emitting particles. So let's change the color of the node and let's take a look at the animation. So notice how this rock stops trailing, which is fine. You may want to tweak again the threshold distance, but I think we're achieving a very flexible system overall.